Hi, Cole. I'm so sorry about the mix-up tonight. Jack did not tell me that you had texted him at 10 after 8 and that he had told you not to come over, and I was waiting for you to come. And I'm really sorry about that. So I think this will be helpful for you, though, because most students I work with find these videos really helpful. So the first question you have right, okay? You've multiplied everything the way you should. Pablo calls this the rainbow. When you're multiplying into the bracket and you've simplified properly, everything's perfect there. Now, if we look at the second one, if I'm reading that correctly, when you multiply this out, you're doing a FOIL on this. So you're multiplying binomials. So we need to multiply this one times this one. That'll give us 30 root 30, because it's root 6 times root 5 under the root signs. Then we multiply this one times this one. That's going to give us minus, what have you got there, 10 root 36, okay? Now this one times this one is going to be plus 12 root 15. And then this one times this one is going to give you 4 root 18. So that's a minus, sorry. Minus 4 root 18, we said. So I'm not quite sure if you had all of that. I don't think you did in your answer there. It looks like maybe you erased part of it or something. So let's just go with what we've got here, okay? So in terms of simplifying, we're going to first look at some of the radicals that could have a square root. So we've got 30 root 30, and actually none of the factors of 30 have square roots. Like, none of them are perfect squares. Think about like 3 times 10 and 6 times 5 and 2 times 15. So we have to leave that as 30 root 30. But with the 10 root 36, the root 36 is 6. So we have 10 times 6, which is 60. 60. And then we have plus 12 root 15, and that won't reduce to a simpler radical. But when we look at the 4 root 18, it will, because root 18 is root 9 times 2, and root 9 is 3, so that can come out of the radical, and it's just 3 root 2, so you should have 12 root 2 there. And now that we go back and check to see if there's anything else that could be added together and simplified, the answer is no, there's nothing else there that could be simplified and added together as like radicals. It's almost like terms, you know. You can only add like an x to an x, not an x to an x squared kind of thing. And so you have to leave this one just like that. So let's just move down here for a minute. I'm going to try and move this whole thing up. There we go. And let's look at the next one. So the next one is you've got a binomial squared here. So what you've got is 3 root 8 minus 4 times 3 root 8 minus 4. And you're going to do the FOIL on it again, the same as the one that we just did. And so 3 root 8 times 3 root 8, do the 3 times the 3, that's 9. And the root 8 times the root 8, you're just squaring the square root of 8, so you're just going to have 9 times 8 there. If you did it the other way, if you had root 8 times root 8, sorry. Okay, the first one, we have root 2 times 5 root 7. So we're going to have 5 root 14. And then we have the root 2 multiplied by 2 root 5. So we're going to have plus 2 root 10. And in the second part, we have the 4 multiplied by 2 root 3. So that's minus 8 root 3. And the 4 times 5 root 6. So that's going to be minus 20 root 6. So now we have it all expanded out. And now we're going to check to see if there's any radicals that simplify. And guess what? There aren't. There's nothing in here that has a square root factor. So we're looking for numbers that multiply to make the numbers under the radical sign, and we're looking for a number in particular that would have its own square root. So like 14 is only 2 times 7, or 1 times 14, and none of those have square roots. And 10 is 2 times 5, and 1 times 10, and none of those have square roots, and so on. So that's actually your final answer for that one. You can't simplify it any further. So I'm going to stop there and send you this video so you can get started. And then I'm going to go back and make you a new video for the other ones that I haven't done yet, so you can see how to do all of those.